It's important to know that gravity affects a lot of variables related to an object. For example, the weight will only really show up on a scale if there's gravity to measure its mass or measure how much gravitational force is acting on this object, the magnitude of this force. And other effects will affect an object equally no matter what mass it has, so you couldn't really measure the weight from that. For example, air resistance, which depends more on the shape of the object and will affect it independent of the mass. So we have a problem which says two identical unlabeled boxes are transported to an orbiting space station. Astronauts know one box is filled with a light sample of ants for an experiment, and the other is filled with heavy tools for repairs. How can the astronauts tell without opening the boxes which box has the tool? So first of all, we need to note that on this space station, it's rotating and it's orbiting, so they're not really going to feel gravity on this space station, so we can't use any measurement that relies on gravitational force and measuring that. So let's look through our options and weigh why each of them could work or cannot work. So the first option A is weigh each box on a spring scale. The box with the tools will have a higher reading. Well, a spring scale relies on hanging the object from a spring and seeing the displacement of that spring, so it shows how much, and the scale shows pretty much the mass of the object by showing how much gravitational force is acting on it and how much that affects the spring. So we can't do that because there's no gravity up there. So option B is shake each box. The box with tools will be harder to move back and forth. This answer does seem correct because it doesn't rely at all on gravity. We know that force equals mass times acceleration, and heavier objects, so acceleration is equal to force divided by mass, right? Yeah, just had to check and make sure, because, but, so that an object which is heavier will take more force to accelerate at the same speed, or at the same, I guess, acceleration as a lighter object, because we need that force to mass ratio to be the same, and if in one case the mass is higher, then in that same case the force will also need to be higher to reach the same acceleration. So this would work. Let's look at the rest either way, just to explain why they're not right. So push each box. The box with tools will travel farther before it stops. This is not correct because if they start off moving at the same speed, they'll decelerate due to air resistance at the same speed, and it won't really be impacted by the mass. So option D is place each box on opposite sides of a balance. The box on the side that goes down lower will be the box with the tools. So let's look at how a balance works. With a balance, both the force acting on both of these objects is gravity. So the one where gravity is acting, which has more mass, so the force of gravity has a greater magnitude, will be pulled down more. And you can see which is heavier like that. But in this case, again, this won't work because we don't have gravity because it's in a space station. So not that one. And E, toss each box straight up. The box with the tools will go higher before coming back down. And I'm sure you can guess at this point why this one wouldn't work, and it's also related to gravity, because the reason things which are tossed up come down is because of the gravitational force acting on them. So the only correct answer is B, shake each box, and the box with the tools will be harder to move back and forth.